Okay, what is minus infinity? How can you start with the most negative answer? I should run till n minus 2. Doesn't matter. I mean, even if you write it like this, it doesn't matter, because even if, let's say, at any point of time your I is n minus 1, then this loop will not run. Okay, so it's immaterial. You can do that. Yeah. So a simple way to initialize your answer to minus infinity is int underscore min. This is available in, I guess, C++. In Java also there would be some other ways to initialize your answer to most minimum value of an integer. So you can check that out and do that. And now what you can do is, every time you can calculate this particular expression for AI, AJ and AK, and if that comes out to be greater than answer, you update your answer. So this is sorted. This is the easiest approach. What is the time complexity of this approach? N cube. Okay, n cube. See, exactly n cube operations will not be there, but almost n cube operations will be there. Because if you try to do that, you can try to do that on your own. Let's say when your I is 0 and j is 1, okay, then your k goes from 2 to n minus 1, which is almost how much iteration? Almost n minus 2 iteration. So you will see that the expression that you will get by adding up the number of iterations, that would be somewhere around n cube. It will not be exactly n cube, there will be many other terms also, smaller terms, but the order of it will be order of n cube only. So this is an approach which solves a problem, but it takes a lot of time, n cube. One more thing, let me tell you. While you guys will try to implement it, you might end up getting many different kind of errors. So let me just tell you, let's say I define their limits in this way, that PQR will be definitely, let's say, smaller than 10 raised to power 5, smaller than equals to 10 raised to power 5. So under this constraint, PQR can belong to integer data type. Can they belong or not? I believe they can, because integers can have value lesser than equals to 10 raised to power 5. And let's say the same is the constraint for this also, that any element array I will also be smaller than equals to 10 raised to power 5. But if you calculate this expression, then 10 raised to power 5 into 10 raised to power 5 might become 10 raised to power 10. And you will not be able to accommodate it in an integer. So you will have to use what? What will you use? You would want to use no, you're not supposed to be taking modulo over here. I want you to actually get the maximum value. Okay, so you are supposed to use a long or long integer. So be very sure about it. Most of you will be getting these errors, especially those who have been out of coding practice. So whenever you are performing any mathematical operation, okay, whenever you are multiplying two things and both are integers, that doesn't mean that the resultant will also be integer. It can very much happen that the resultant will be greater than integer. So you have to store this value in a long or long. Okay, so please take very good note of it. Okay, so this was one thing in which the time complexity was n cube. Yeah, let's now try to improve it. So somebody is saying that, hey, what I'll do is I'll simply sort the array. Okay, if you sort the array, then you can easily get the 3 maximum elements, because those 3 maximum elements will be in the end. And you will say that, hey, first element I'll take and multiply with P, second I'll take and multiply with Q, and third I'll take and multiply with R. Is that the right thing to do? Why is that not the right thing to do? Because PQR can be negative also, right? Think of it in this way, that if, let's say, my P over here was -1, okay, and let's say this element happened to be -1, okay, then what would you have done? With which element you would have clubbed this P? Would you have clubbed this P with 3, 2, -1? Which one? You would have clubbed this with -1, right? So the technique that you are thinking of picking up the 3 maximum numbers and then multiplying them with P, Q and R, that is not the right technique. Let me just change this for now a bit. I'll ask you a simple question. Now what I want to do, I forget about this. Think like this does not exist. Okay, just think that the array is given to you. array containing n integers is given to you, and you simply have to maximize this expression that I am going to write now. This is array I plus array j plus array k. You simply have to maximize this expression under this constraint that I is smaller than j is smaller than k. How will you solve for this question? With respect to this element, is it right to say that simply take 3 maximum elements and their sum will be the answer? Can I say that? Actually, I can say that. If you try to use some more thought over it, I can say that. Think of it in this manner, that if this is your array, and let's say the 3 maximum elements are 10, 7 and 5. Okay. Now, let me ask you one thing. If you forget about this rule for a while, then can I say that the sum of 3 maximums will be the overall maximum? Can I say that? If you forget about that rule. But even if that rule is imposed, then also is there any problem? There is no problem at all, because instead of taking this as array I, this as array j and this as array k, you can always choose this as array I, this as array j and this as array k. So that will ensure that, see, you have 3 elements located at different indices. So you choose this as first, this as second and this as third, and your job is done. So it's just a matter of picking the 3 maximum elements and your job gets done. So in this kind of case, I'll simply have to pick the 3 maximum elements. So with respect to this question, what will be your time complexity? If you go ahead and try to solve this, what will be your time complexity here? So the best case could be order n, because see, one way to easily figure out 3 maximum elements is to sort the array and pick the last 3 elements. But if you sort the array, how much time will be taken? N log n. Okay, and then you can pick the last 3 elements. So that is the n log n based approach, but you can do it in order n time also. Can you do it in order n time? You can do it, because if let's say you have to figure out just the maximum element, to figure out just the maximum element, do you sort the array? No. You write a single for loop and figure out that maximum. Can you similarly figure out 3 maximums? So you can write in 3 passes. So you can write a first for loop where you get the overall maximum. You can write second for loop where you get the second maximum, and third for loop where you get the third maximum. However, you can do it in 1 pass also. Think about it, but this is quite doable in order n time also. Okay, so everything is cool till here. I would like to say that think of this question from a different perspective. Okay, how to think it from a different perspective? So whenever you are given this kind of expression, let's say you have to maximize array I plus array j plus array k. So even when you were, writing the brute force approach, in the brute force approach you were considering all triplets, right? So, and the way you were considering the triplets was something like this, that if you were choosing your index I to be 0, then your j and k were something which belonged from 1 to n minus 1. Okay. Now there could be multiple pairs over here. For 1 you can have 2, 1 you can have 3, 1 you can have 4. Okay. For 2 you can have 3, 2 you can have 4, and so on. So fixing the terminal element, which is this or this, is rendering me with multiple options for the remaining 2 elements, isn't it? So can you tell me that which element should be fixed so that I can ascertain that I can figure out my remaining 2 elements in a very fast way, rather than considering all the pairs or something. Middle element. So how many of you feel like that fixing middle element is going to help us? So fixing middle element is actually going to help us, because think of it in this way. Let us take a generic example. Let's say this was your array, this was index 0, this was index n minus 1, and you fixed your j at this particular location, and you have to maximize this expression. So your array I must belong to this portion and your array k must belong to this portion. Now can I say that if at all you have to pick something from here, you would want to pick maximum thing from here, and the same logic goes here, that if at all you want to pick something from here, you would want to pick maximum thing from here. Is that clear to everyone? You would want to pick the maximum from the left part and maximum from the right part. Can I say that this maximum should actually be the maximum element from index 0 to index j minus 1, and this maximum should be the maximum element from index j plus 1 to index n minus 1. Now tell me one thing, can I say that this particular thing is the prefix max till j minus 1? I can denote this as that if this is the prefix from 0 to index j minus 1, whatsoever is the maximum in this portion, that can lie over here. And similarly, I can say this thing as suffix max. So suffix max of j plus 1 simply means that what is the maximum from index j plus 1 to n minus 1. Let's take an example. I'm just trying to give you the concept behind this. So let's say you are trying to construct prefix max. Okay, let's say you had 5, 4 and then 9. So this was index 0 and this was index 2. Okay, so what will be prefix max of 2? Prefix max of 2 will mean the maximum element from 0 to 2. What is the maximum element from 0 to 2? That is 9. So prefix max of 2 should be equal to 9. Now tell me, if I want prefix max 3, what is the physical significance of this? The physical significance of this is maximum from index 0 to index 3. If you know this value, can you calculate this value very easily? That is very easy, right? Because prefix max till 3 will either be maximum till here or this element itself, because if this element is, let's say, smaller than this 9, which is maximum till here, then the answer for this will be same as the answer for this. But if this element is, let's say, greater than this thing, then the answer will be this element itself. So can I say that prefix max till 3 will be maximum of 2 values, and those 2 values are maximum till here, which is prefix max till 2, or this new element itself, which is array of 3. So here I can say that this way I can calculate the prefix max in a very easy manner. And now can everyone write a code for this? If you were to, let's say, generalize this, you can very easily generalize in this manner. You can say that prefix max ending at index j, prefix max till j means what? From 0 to j. Okay, what is the maximum? Okay, this thing will be max of prefix max till j minus 1 comma array of j. Okay, this is the way you can populate the prefix max array. So to start with, what would you want to do? You would want to create an array int prefix max of size n. Okay, now to find the answer for j, to find prefix max till j, you need prefix max till j minus 1. So would you want to initialize this array in some manner? Can we easily initialize the value of prefix max of 0? What should be the value of prefix max of 0? It should simply be a of 0, right? Because the maximum element from index 0 to index 0 should be a of 0 itself. So what I can do is prefix max ending at index 0 should be a of 0 itself. And now for all the other elements, for I varying from 1 to n minus 1, I can simply write that prefix max till I is maximum of these two things, which are prefix max till I minus 1 comma array of I. So this way, in just order n time, you have been able to construct this prefix max array. Now the way you have constructed prefix max array, can you construct suffix max array also, which is maximum from n minus 1 till index j? You can do that easily, right? So you can have an integer array suffix max, again of same length. Okay, and which element would you want to initialize over here? Would you want to initialize the first element like this case, or would you want to initialize the last element? It makes sense to initialize the last element because suffix max from index n-1 to n-1. So what does this physically mean? What does the suffix max of j means? This means that if you consider the portion from n-1 index till index j, then what is the maximum in this portion? Okay, so you can initialize the answer for this much part very easily. That will be array of n-1 itself. So you can assign suffix max of n-1 as array of n-1 itself. And now for all the other values, you can build them very easily, but you will build them in reverse fashion. So you can start with j equals to n-2 and you will go till 0 by doing j minus minus. And now you can apply the same rule. Suffix max, I am writing this as sm, the short form. Suffix max ending at index j should be maximum of suffix max ending at j minus 1, j plus 1, okay, comma array of j. So this way you have constructed this also in order n and this one also in order n. Is that clear to everyone? So now you have prefix max values till every index and you have suffix max values also till every index. Did everyone follow that? Is the code clear to everyone? Will you be able to do that? Okay. Now in order n time, once you have got these two arrays, can you find the answer? Can you solve the problem of maximizing ai plus aj plus ak using this? You can very easily do that because the moment you consider this as your aj, okay, whatever is your maximum in this part, that can come out in order one time. So the maximum of this part will be prefix max ending at j minus 1 and the maximum in this part will be suffix max starting at j plus 1. Okay, so one by one you will consider all the elements as j and then you will check for prefix max of j minus 1 and suffix max of j plus 1. But be careful just about one thing. How can we decide when to pre-compute the value as of here? Okay, we'll see some examples and from that you will get to know. Yeah. So here an important thing to understand is that whenever you are fixing your j, okay, then your prefix max has index j minus 1 and this has index j plus 1. So is there a chance that you end up getting index out of bound exception because of doing j minus 1 and j plus 1? You can get that, right? Because if your j is 0, then j minus 1 will be minus 1 and j plus 1 will be n if j is n minus 1. So whenever you are dealing with indices in this way, then you please take note of this thing whether you can end up getting index out of bound exception or not. So that is solvable using common sense because your a of j, can it ever be index 0 or can it ever be index n minus 1? No. It will always be some middle element. So you will iterate from 1 to n minus 2 only, okay, which is this sandwich part between these border elements. And now when you are fixing, let me call this j, when you have fixed your a of j, then you know that from this part the maximum element would be stored in prefix max of j minus 1 and in that part the maximum element will be in suffix max from j plus 1 and to this you will add the jth element that you have considered. So this is your value of x. Now if this x is greater than your overall answer, so you would initialize your answer to minus infinity, then you can change your answer to max of x comma answer. This way you will be able to get your job done. Okay, what is the overall time complexity over here? The time complexity is order n because in order n time I constructed the two arrays and in order n time I applied the core logic also. And what is the space complexity here? Did I use some extra space? The answer is yes. I ended up creating two more extra arrays. But answer me one thing. Can I get my job done with just creating one extra array rather than creating this and this both? Can I just create one of them and still get my job done? Answer is yes, and it is very easy to think because think of it in this way. Let's say you are starting iteration from j equals to 1. Okay, so whenever your j is over here, you need maximum till this point. Okay, now when your j is, let's say, here, then you need maximum till this point. You can track that by using a simple variable max also. A single variable max that can keep tracking the maximum element encountered till now. And then you just have the suffix max array so that you get to know the maximum in this part in order one time from this part. So you do not actually need this thing if you try to implement in this manner. Okay, so what I am saying is that let's say when you are computing maximum element in an array, how do you compute maximum element in an array? You simply write a for loop and then you keep changing that max value. Whenever you are at index j, then the value of this max variable contains the maximum element in this part, right? So you can just have that max variable which you are updating on and on and on, and when you would be at index j, you would have maximum in this part stored in this. So you can just use that variable to add to suffix max and the answer and get your job done. You do not need to construct an array to store those. So this is an approach that we all understood, order n time and order n space. Now, can you apply the same logic to solve the original question that asked you to maximize p into ai plus q into aj plus r into ak? Can you apply the same logic over there? So see, this is a kind of important technique that we have learned just now. That technique is called as prefix computation. You compute prefix max, that is what you are doing. Sometimes in some questions you compute prefix sums. Okay, so you will get to see a variety of problems where computing a particular entity, it could be max, it could be sum, it could be product, it could be anything, from one particular end makes our job very easy. Okay, so this was one such kind of problem, and now how it can translate to that, let me tell you. Are you guys thinking, how many of you are thinking that to solve this problem I might need to track prefix max as well as prefix min, suffix max as well as suffix min? Is there anyone who is thinking like that? Because p, q and r can be negative also. So someone who feels like that. So that is not required. Why that is not required? Because think of it in this way. Whenever you fix your a of j, you would need the maximum, you would need an element from here from 0 to j minus 1 such that p into a of that element x is maximum. So what you can do is, instead of storing the maximum value of element in this portion, you can store the maximum value of this expression. So now your prefix max that ends at index j minus 1 stores the maximum of p into a0, p into a1, so on till p into aj minus 1. So now I will simply store from this end that what is the maximum value of p into a of j in the left part. Guys, did you follow it, what I am trying to say? It's simple enough, right? It's just that instead of element itself, I am storing the maximum value of p into a of this particular j, and the same thing can be done in this part also, right? In the suffix max ending at j plus 1, you will store not the maximum element but the maximum value of this particular expression, sorry, r into this, maximum value of r into this. Now this becomes very easy. So now whenever you fix a particular j, okay, then you know what was the maximum value of this expression from left. Let's say that maximum value was m1, and let's say in this part that was m2, and to these two you will add the contribution of this element. That contribution will be q multiplied by this particular element. So this way, in order n time, you will be able to solve this question. So p, q and r were just given to to trouble you a bit. They were just given to put you in some kind of confusion. Okay, here also space complexity will be order n. Yes, you will need to maintain at least one extra array to do that, prefix array or suffix array, whatsoever. So PQR was just given to confuse you. The concept here was, the underlying concept here was to perform prefix and suffix computation only and then get your job done. Please explain by taking an example. Okay, using priority queue, we can do it in place. But if you use priority queue, your time complexity will increase because when you are using priority queue, and I'm not sure how using priority queue, you will maintain the indexing also, I, j, and k. Okay, so, and if you are using priority queue, you are using an extra space for sure, right? I mean, what do you mean by in place? Do you mean using no extra space, or what do you mean? Or has it got something to do with stability without extra space? But you are saying that if you're using priority queue, you are using extra space, right? I'm not sure how your algorithm runs, but if you are using priority queue, you are using extra space for building that priority queue. That is what I am assuming. Is that right, or is there something else that you are trying to say? Yes, no, what do you have to say? Okay, Dilip, yeah, I think you meant that. Okay, just let me know if you meant something else. So Dilip, I mean, by example, it would be very long. I mean, examples are required for questions where you don't get the conceptual part. If you understood the conceptual part, then what is problem over here, that you tell me. This approach is correct. I can mathematically prove it, and I already proved it, because whenever you are at whatever triplet you will choose, that triplet will have some value of a of j, some value of a of j, right? Now I am considering all those a of j's. I'm not missing out on any. I'm considering all those a of j's. Now whatever aj I am considering, for that I am picking the best possible p into ai and best possible r into aj. That's it. So it makes sense, right? Did you get it now, or do you feel still there is a need of some? So yeah, what, you understood it, or do you still have a doubt? You don't need a test case or something to run to verify this particular logic is right or wrong. You can simply code it out and you can check whether that is working or not. Okay, so how many of you can code it? Just say yes, those of you who can code it on your own. This is not a complicated question, by the way. Let me tell you, this is not a complicated coding stuff. There was just a concept that I wanted to talk about, which was prefix computation. That's it. Prefix and suffix computation, how they make our life easy. Okay. Pre-computation, these are also called as pre-computation. You pre-compute something, okay, from some particular end, and then you can solve the actual problem in a very easy manner. Cool. So this question will be there in your assignment. Make sure all of you code it. Be very aware about one thing. Here the constraint that I had imposed on indices, that was like this. So you might end up seeing a question where constraints can be like this also. So something will change, isn't it? If the constraints are like this, will something change or not change? It will change. What will change? Because now a particular element can be taken 2 times, 3 times, many times, isn't it? A particular element can be taken multiple times. Let's say a of 5 can act as ai also, and can act as aj also, and can act as ak also. This constraint simply means that an element can be taken more than one time also. Okay, so something will change. I leave that up to you. Very small and easy exercise. All of you can do that.